Hi, we're continuing our video series using physics and computer code to simulate projectile motion. In this lecture, we're just defining position, velocity, and acceleration. I'm going to try and help you get a feel for what all those things are. Hopefully you already know what some of them mean. We've talked about acceleration before, but I'm going to try and explain it a little bit more in this video. Here's where we are in our video series. We're on video 3. If you don't know, if you just started on this video, I recommend going back and watching the others. So this one's on position, velocity, and acceleration. So first, let's start with some basic definitions. So the position just means where an object is, and this can be relative to something. So like a distance. Dave is 14 meters or 14 feet away from me. So the velocity is like the speed. It's the rate of change of position with time. So if you're driving somewhere and you need to go 100 miles, you can figure out how fast you're going to get there if you know that you're going 50 miles per hour, for example. So that 50 miles per hour is how fast your position is changing with time. So it has those units of miles per hour, but that could also be in something like meters per second. Acceleration, I think, is the term that is probably new to some of you. This is how fast your velocity is changing with time. So just to help these things kind of sink in, I'm actually going to ask you some questions in this video and have you think through them. So when we were talking about free body diagrams, we talked about our guy falling from the sky. Poor guy, he does have a parachute. So let's say our guy deployed his parachute and he is falling at a terminal velocity, which means he's falling at a steady velocity, meaning the force of gravity is equal to the drag force. So he's no longer accelerating. However, he is falling at this constant velocity. So if he is falling at a velocity of 10 meters per second, how far will he go in 10 seconds? So think this one through. So his distance or his position, let's say, if he's falling at 10 meters per second for 10 seconds, his position would be 100 meters. It would be 100 meters different from what it was before. So this is pretty simple. This should be straightforward. Hopefully that was an easy question for most of you. So if we wanted to calculate the position, we can say the new position is equal to the old position plus the velocity multiplied by time. So in this case, if we said our old position was just 0, the velocity is 10 meters per second, and time is 10 seconds, then we could get the new position. Let's say the old position was just 0 plus our velocity of 10 meters per second multiplied by 10 seconds would give us, he would fall 100 meters during that time. And I think my video is covering that up. So he would fall 100 meters during that time. So we have 10 times 10 is 100. The units here actually cancel out just like numbers. So here we have 10 seconds in the numerator. Here we have seconds in the denominator. So that ends up equaling units of meters. Let's take a look at another problem. So our guy is falling from the sky. In this case, he just jumped out of the plane. He doesn't have his parachute deployed yet. So when he first jumps out of the plane, his downward velocity is equal to 0, but he's going to be accelerating at a rate, I introduced that gravitational constant, we're going to round that in this case. He's accelerating at 10 meters per second. So what will his velocity be? So what's the new velocity? That is supposed to say new. After 10 seconds. So give this a minute to think about it. If he starts out, he just barely jumped from the plane, so when you first jump out, your downward velocity is just 0, but gravity is causing you to accelerate the whole time, and that is approximately at a rate of 10 meters per second every second. So his new velocity is what after 10 seconds? So hopefully this is, again, some easy math. His new velocity in this case would be 100 meters per second. So we can apply this formula that the new velocity is equal to the old velocity plus acceleration multiplied by time. So in this case, that new velocity is equal to 0 if we're starting out at just jumping from the plane, plus this 10 meters per second multiplied by 10 seconds. And what do we get? Again, our units cancel out and we get 100 meters per second. Okay, so these formulas are going to be important when we move into the computer coding part of this. And here is why. If I asked you this same question as at the beginning about position, let's say that our guy just jumped from the plane. He's starting at a distance of 0, and he's starting at a velocity of 0, and he falls for 10 seconds. So what is his new distance, or what is his new position after 10 seconds? So think through this one, see if you can figure this one out. What is his new, he started with a velocity of 0 and a distance of 0, and he's falling for 10 seconds. What is the new distance? So this is a kind of a trick question. This is actually quite a bit harder, and the reason is he's not falling at a constant velocity. His velocity is changing. So we just solved this problem before. If we know that his acceleration is still approximately 10 meters per second, again, this is very close to the gravitational constant for the Earth. So anybody or any object dropped from a plane would have the same gravitational constant. So applying this, we know that the new velocity, because this is constant, our acceleration is constant, our new velocity we know is still going to be 100 meters per second. However, the trick here is that velocity has been changing every second that he falls, so we can't apply this same formula exactly for distance. And why is that? That's because if we looked at that old formula that I showed a few slides ago, the new position is equal to the old position plus velocity times time. However, the trick here is what velocity do we use, because the velocity is different every time. If we wanted to look at this graphically, if we were to graph, here's time, and here is acceleration. In this particular case, due to gravity, here is velocity with time. So we're only thinking about acceleration due to gravity, and remember that is a constant. So that number does not change with time. He just has this constant acceleration. His velocity, however, it gradually increases because you're constantly accelerating, so your velocity is changing all the time. So our position with time actually does something funky. It's a curve. And that's because this velocity is changing with time. The basic thing that we figured out here is we can't calculate position as simple as using this formula. And why? That's because the velocity is changing all the time. And this is where computer coding is going to come into play. So what we're going to do as we get into computer coding is we are going to be calculating all of these things in steps. So we're going to break time up into tiny little steps. And at every step in time, we're going to be able to calculate what someone's position is. So we're going to write computer code that helps us to deal with the fact that velocity is changing all the time and even acceleration may be changing all the time. So what we're going to do with this computer code is we're going to be able to look at our object falling through, in this case our guy falling through the sky, and what we're going to do is we're going to break up time into small little chunks. So we're going to look at time at 0 seconds, we're going to look at time at like 0.1 seconds, time at 0.2 seconds, and so on. So as time advances, our guy is going to be falling, and each time step we're going to calculate a new position and a new velocity and even new acceleration terms. And so what we will do is we'll use code to simulate this guy as he's falling, or to simulate our object as it flies through the sky. And we're going to break up time into these little small chunks, and at every time we're going to calculate updates of all of these. And we will use that same basic formula. For position, it's going to be that our new position is equal to our old position plus velocity at that particular time times multiplied by our little increment in time. And so you'll see that you can have actually pretty complicated interactions happening here, but you can do this. We're going to make it a lot easier by using computer code. So stick with me. We're going to get into the coding part in our next video lecture.